Okay, I'm going to talk to you about section 6.2, the formula section in the algebra chapter. So if you look at section 6.2, formulas, you're going to find a lot of equations that some you may be familiar with from other classes and some may be new to you, but the idea is we're going to practice using these formulas and solving for one of the variables. Well, the first one that you'll see is simple interest. Simple interest, I will call that equals P times R times T. That's the principal, how much you borrowed or you're saving, times your rate of interest, and then times time. Unless otherwise stated, it's a per year annual interest rate, and so time should also be in years. These should always be the same type of unit. So if it's an annual interest rate, which like I said typically it is, then time should also be in years. All right, our first example we have is, say someone borrowed $4,000 at 2.9% for 3 years. What would be the simple interest? So our formula I equals P times R times T. We're missing the simple interest part, so we don't know I. Sometimes they leave out different parts, so they can leave out any one of these variables, but the first one starts more straightforward, where you have the principal. And then let me talk to you about the rate. Every time that we use a percent and we put it into an equation, it has to be converted to a decimal. So you move your decimal point 2 places left, makes it 0.029. So always note to do that, 0.029. And then time, it says is 3 years. So from there, we type it in our calculator. So just straight up, it's all multiply there. We'll give us I, and that should be $348. So that's the interest that you will owe for borrowing. If you borrow $4,000 at that percentage, that's pretty low interest rate. You might think that seems pretty low, but man, they're going to make you pay $348, well, over the course of 3 years, but you do pay for the use of that money. Now, another question, that's A part to this, is how much is interest? But B part is then how much do you totally owe back? We've got to pay back your $4,000 that you borrowed in the first place, then plus you'll have to pay the interest, $348. So your final answer there is the total amount you have to pay back is $4,348. Okay, if they ask you that. All right, let's try that again. This time, let's leave out different parts. Same problem. Let's say we don't know how much money we borrowed. So that'll be our unknown. And let's borrow it at 7%. And for, let's do 5 years. You know, we could change these around anyway. And let's say the interest equals $592. So now we're going to use this same equation and put in what we've got. You can always just leave out one place and they can ask you this question in many different ways. This time I know the interest that I owe is $592. I know I. P is the unknown, so we can either call it X, you can call it any variable you want actually, but I'm going to use P from the formula. Principal is what I don't know, how much money I borrowed. The rate, 7% needs to be changed to 0.07. Again, move the decimal point wherever it may be, 2 places left, 0.07. And then the time here is 5 years. So we'll plug that in and then we'll equation solve this. So go ahead and simplify each side as much as you can. We can multiply this 0.07 times 5 and have P times 0.35. And then what we learned in the last section is equation solving to solve for P, because P is multiplied, understood that's P times these two. The opposite will be to divide by the 0.35 to get that to cancel. We do the same thing always to each side to keep the balance. So now that's canceled out. We've just got regular P. P equals, and we type this on our calculator, 592 divided by 0.35. And it comes out, we want it to the nearest penny when we're talking about money, so you go out 3 places. You'll have to go to the 3rd place. Let me just show you that. On my calculator, it says 1691.4285, yada yada. But to the nearest penny, you know, you need, that's your penny penny place. So you have to go to the 8, and the 8 says round that up to 3, so it's 1691.43 cents to the nearest penny to be accurate. All right, so with all the formulas we go through, sometimes they tell you all the things on one side and you're able just to use your arithmetic and type it in your calculator, and then other times we have to use our equation solving technique. All right, let's talk about another formula. There are many. These are just some sample ones. This is a volume of a box. Example 2. Volume of a box is its length times width times height. The 3 dimensions multiplied together tells you how much volume or space is inside of the object. So in this one it tells us, if you're following along, it says the formula for the volume of a rectangular box is volume is length times width times height, or V equals LWH. And find the width of a rectangular box of ice cream if the length is 7 inches, and the height is 3.5 inches, and the volume is 122.5 cubic inches. So do not dismay. The cubic inches is just on there to tell you that that's the measurement that is used, but it won't necessarily affect your formula how you put it in, because when we take inches times inches times inches for these 3 units, it becomes cubic inches. So the volume is naturally in cubic inches. But when we input it into our formula, under volume, that number is given 122.5. Again, you don't need to put in the unit. It's just part of knowing that it's there, but it's not in the formula. Length is given as 7 inches. Width is unknown. And then height is given as 3.5 inches. So to simplify this, these are all multiplied together, so you can go ahead and multiply the parts that you're able. The 7 times the 3.5, go ahead and jump those over together. 3.5 times 7 is 24.5, and then put the W on the front or the end, but it's still times onto that, but we just don't know what it is because we have to equation solve. So now we got 24.5 times W equals 122.5. To equation solve this, because it's multiplied, we'll do the opposite operation and divide by the 24.5. Those cancel each other out and actually becomes 1. Anything divided by itself is 1. So you've got 1 W, or W, regular W. What you do to one side, we'll do to the other side. And then we'll punch that on our calculator. And that comes out even. It doesn't always come out perfect, so don't think you're wrong if it doesn't. Sometimes you have a decimal. This one came out nice and perfect. And we would know it's in inches. It should be 5 inches. So now we could check. Is 7 inches times 5 inches times 3.5 inches multiplied together should be, we could check 122.5 cubic inches. And so you can verify that. But our answer is that 5. All right, next example. This is going to be the last chapter that we do, but the third example is with a statistics formula. Z equals x bar minus mu divided by sigma, lots of Greek alphabet here, divided by the square root of n. So these formulas will be given. You don't have to memorize these, but we're just going to practice putting in values for it. So it tells you in the reading to plug in all but one of these things. It tells you x bar, which is going to be the mean whenever we study statistics, minus the u is 100. All these are just given numbers. Sigma is given as 16, and n is given as 4. So we input all the values, and then here's the big thing about this section, and a lot of things we do in math, is how do you get that in your calculator? What's the right order of operation? So there are kind of 2 different ways to work this, one more by hand and one on your calculator. So let's talk about that. If you were going to type it in your calculator, it would be really hard to type in just directly. And the reason I would say is you got to remember that's your main division bar, and you have to tell your calculator where your division bar is. Some some of the simpler calculators, even the $10 scientific calculators, have a button that will kind of separate those. So if you have that, then you won't have to worry about this. You type it in the way it looks. Some calculators will let you do that. The typical calculator, you will need to tell your calculator that's the numerator and put a parenthesis around it. And you'll need to tell it that's the denominator and have a parenthesis around it to be most careful. So you would type it in. If you wanted to totally do this on your calculator, you'd need to parenthesis that, then say divided by, parenthesis 16 divided by, and again, this would be a question for some of you too. Some of your calculators, you type the square root button before you hit the 4, and some you hit the 4 and then the square root button. So you'll just have to kind of see which way yours works best. But for mine, I do the square root button and it puts the 4 in there. And then hit it, and it will just work it out. To do it by hand, which is probably more my style, that way I can control where the parentheses, I might forget one or something, I would just work it. 120 minus 100 is 20. Then next in my order of operation, I would do the square root, make that a 2. Then I would say 16 divided by 2 is 8. And then I would reduce 20 divided by 8. If fractions are preferred, you need to keep it as, let's see, what would that reduce to? 5/2 as a fraction, or if you can do it as a decimal, that will 20 divided by 8 is 2.5. So you check your work. All right, next example I want to talk to you about. This comes up in your homework set. It's probably my most asked question that I get from the class, and it's using the, let me find it, the formula that looks like this. We will be using this formula. A lot of these we use later on in the class when we do statistics, and this one will be in the business math section. So it tells you the compound interest accumulated amount. So we have simple interest, we have the I equals PRT formula, and then we have compound interest, which adds in your interest incrementally and then adds on your, so if you were saving money, for example, and you saved $100 and you got 5% interest on that. So at the end of the year, you'd have $105. Well, the next year, your simple interest would be figured on that $105. You'd have a bigger base they would base your accruing off of. So the compounding adds in the interest incrementally, either monthly, every month they add in your interest, or the example I was saying, like every just once a year annually, or maybe it's semi-annually every 6 months. So they add the interest in incrementally, so you have a bigger base of principal. So this formula does that for you, and you don't really have to know that yet. We'll use it later and talk about it, but we're just practicing using a formula. So let's say we knew the principal was $100, and we're looking for A. The rate, R is for rate of interest, say it's 6%. N is told to be 6, so we use it here and here in this formula. N's repeated, and then maybe for T is 2 years. So to type this in our calculator, like I said on the last example, you can do it by hand sum, or if you were doing it by calculator, you need to tell it times, either with your X sign or however yours is. And some you don't even need anything between that and the parentheses. Your calculator knows it's times. You just kind of have to play around with your calculator and see, you're getting the right answer and how it inputs. But that is usually pretty clear to my students, that part. But here's where the mistake is usually made. After you do that part, this is an exponent. So you need to tell your calculator to make that an exponent, either with a caret or the XY button. That's one of those is probably on your calculator. Then, if you only put 6 times 2 like that, your calculator doesn't know that both of those are exponents. So you would be required to have a parenthesis around that to get that right. Otherwise, I would say, why don't we just go ahead and 6 times 2, we all know that's 12. Just go ahead and put it in as 12, and then you don't have to even remember a parenthesis. So by hand, I would do what's in my parentheses first. I would type that in my calculator. 0.06 divided by 6, and then add the 1 is 1.01. I would need to take that to the 12th power with whichever operations on your calculator. put a lot of numbers down for these two. Don't round off too much until the very last